let's continue looking at some other ways we can display data. So next I'm going to look at a stem and leaf plot. You might have seen these before. They do come up, but it's probably been a little bit. So what I'm going to do is I'm going to split my data into the ones place, and or in this case is the ones place is going to be whatever is going to be furthest to the right. So for instance, this 15 I'm going to split up as 1, 5, and the 58 I'm going to split up as 5, 8. We can have decimals here, but we're always going to have split into what's the stem and the leaf is just going to be the furthest to the right. My smallest number in this case is 15, so it starts with a 1, and my largest number is 58, and it starts with a 5. So over here on the stem part, I'm going to go from 1 to 5. And I'm never going to skip anything. I'm going to use every number from 1 to 5. Now I'm going to place in numerical order the ones places that come after this. So 15 is the only number that starts with a 1. So I'll place it. That one's pretty easy. Now I have a lot that start with a 2. So I'm just going to kind of look at all of these guys. Let's see, there's a 28 too. 20 is the smallest, so 0 represents 20. Next I would have a 27, a 28, a 29, and let's see, and there's another 29 as well. And I do have to repeat things. There were 2 29s, so I'll put them both there. I do put them in numerical order, and I do try to line them up so they're kind of on top of each other. There. And this can be a little like picky. Some people don't like when I say it, but we're not going to put commas in between there. My math lab is going to tell you they do not like them separated by a comma. So just a space and then a new number. I'm going to do the same thing with the 30s here. So anything that starts with a 3, so I've got 6, 6, 7. Again, try to line them up. You don't have to color code it. I'm just taking advantage of having that. I have lots of things that start in the 40s. We're going to put them in numerical order. And you might miss one at some point. I have done this one before, pre-done it, so I made sure I don't miss one. But just erase and do it again. This is one of the things where, you know, a pencil probably a little bit more handy than a pen, because it's very likely that you could miss one. And you might have to go back and add one in. And they do have to be in numerical order. So if you miss one, you can't just like squeeze it in. I'm going to do the last one's a 5. So I'm going to put the ones place for each one of those guys. Again, using any repeats, writing them twice. One thing we do have to include, a lot of people forget this, is the key. The key tells me what these numbers stand for. That's basically what are the units. Choose any number you want. I'm going to choose the first one because it's the first one I see. This 15 refers to the hours that they've spent studying. So that's my key. Don't forget that. That's always part of the points of the problem. So you do want to include that. That just tells me what that number stands for. It also tells me if that might be 1.5, 15, or 0.15. Stem and leaves don't include decimals, so it kind of gives me that place value for the numbers and also includes the units. So super important. All right, the rest of the stuff that we have to do is just reading graphs. So hopefully this feels like a review. It's okay if it doesn't, but I wouldn't be too upset if I were you if this seemed easy, because I'll take any of those easier questions that might come up. So we've got different graphs here. I'm going to start with a bar graph. So I've got this bar graph right here, and I'm just going to have to read this one, just the example we've got here. So this is a double bar graph. It shows the males and females athletics at a university over a 4-year period. What percentage of all students involved in athletes in 1986, so 1986, were female? So the number of female students, it looks like, are 150. So that's my female. And they said what percentage of all the students in 1986. So all the students in 1986 would be 200 plus 150. So that would give me 350. That's the total number of students for that year. I'm going to type that in my calculator, and it's going to give me a decimal place. And I want to round to my nearest percent. So remember, we move the decimal place first and then we round. This one wouldn't really matter too much, but sometimes when we have to round to a tenth or 100th of a percent, it does matter. So move the decimal, then round. So that would give me 42.857%, which rounds to 43%. No real trick on most of these. We've got a couple other reading graphs here. This one we've got a circle graph. These bar graphs are usually used for like categorical data there, where we've got male and female. I'm splitting those up. The circle graphs are going to be comparing parts to wholes. Sometimes they're called pie charts as well. So what percentage of her expenses is for food and rent? So I'm just going to add those together. So the food was 30% and the rent was 25%. So that gave me 55%. How much did she spend on rent each month? In my original directions, I'm told the total, and rent was 25%. So I'm just going to change that to a decimal and type in that in my calculator. Get my answer. So just making sure we can read data off of a graph or a data display that's given to us. Now these next two, the first one is kind of a little wonky. The second one maybe feel a little bit more comfortable with. These are different types of line graphs, so we're just kind of following the line that goes here. So this one is a real retirement guide here. So we've got someone over here. We want to know on average 12% annually, what is the maximum net worth Claire could achieve. So she's in this 12% range here. The maximum is going to be at the top of the 12% mark. So that's going to be $800,000. At about what age would that maximum occur? You know, it's going to be somewhere in here between 75 and 80. It definitely is not at 75. She's a little bit lower, and 80, she's even lower. So somewhere between 75 and 80. I'm just going to go with 77, but I'm going to put the approximation on here because I would take several different answers for that. So not just that one. So if you would put 76 or 78, I also would have taken that. All right, last one. The total sales for the first 6 months in 2009. So 2009 is this bottom one. And we want all the first 6 months. So I've got to add everything together through month 6 there. So all those little dots, I'm going to actually erase them so we can read a little bit easier. So for the first month, we're at 48. The second month, we're halfway between 48 and 52. So you might could do that in your head, you might could look at it, or you can add it up. 48 plus 52 divided by 2 is going to give me 50. The next month, I'm down at 44. Again, I'm halfway in month 4 in between 44 and 48. That gives me 46. You can think about in your head. You can type in your calculator, 44 plus 48 divided by 2. Some people kind of look at it visually. Whatever works for you. 52 for the next one. And for month 6, that's the last one we had to do all the way through the first 6 months. I'm back to that 50, that halfway mark. I am going to add all those up and I get 290. We do need to make sure on this one, I'm going to move that plus 50 over so I can show you that this is in thousands of dollars. So I'm going to write 1,000 on it because there's a big difference between $290 and $290,000. So it is $290,000 or our sales for the first 6 months.